starting with the model number 5 for the second day, uh, configuring Azure pipeline. So in this, we are going to understand about the pipeline concept, how to develop a pipeline, what is the component which is there in the pipeline, and how we can create Azure pipeline. So pipeline concept of the DevOps first, and then we are looking at the Azure pipeline. We'll be looking at the how our evaluation of the self-hosted agents. So actually, when you are going to run a pipeline, it's using a machine to run those codes and try to build or test. So it's required some machine. Okay, so Microsoft also provides some machine. So that is called Microsoft hosted agent. You can also deploy those agents into your VM, into your on-premises environment. That is called self-hosted agent. So we'll talk about that, how Microsoft agent works, what is the self-hosted agent. We'll understand about the concept of agent pool. So agent pool is a collection of multiple agents. You can deploy multiple agents, 5, 10, whatever is required, those agents you can go ahead and deploy into your system. We'll be looking at the concurrency, how we can run a parallel. Like I want to run a job at the same time, maybe in the night 12 o'clock or the morning 10 o'clock, which I need to execute 2 or 3 or 4 jobs. How I can go and run a parallel job. So we'll be looking at the parallel job, how many parallel jobs we can execute. We'll be looking at the Azure DevOps and the open source projects, so how we can deploy public projects, how we can deploy our private project. We'll be looking at the YAML way of developing of our pipeline. So there's two way of developing of pipeline or creating of pipeline, you can say. One is the classic way of the it comes as a UI where you drag and drop all those things and you start building your pipeline. Other thing, there is a YAML script. If you know the good into the YAML script, you can start building a YAML pipeline as well. So now that has become famous nowadays in the YAML script. So you should learn and understand the YAML way of developing a pipeline as well. So these are things which we are going to touch base into this module. So let's start with the pipeline concept. What is the pipeline? Why we have to use a pipeline, and what is the benefit of using a pipeline? Okay. So as you can see in this screen, okay, so pipeline is going to use a build, automation, and the continuous integration. So you are going to build your application, continuously build, you are going to perform, you are going to do a testing, so you can perform some unit test case, or the application testing, which you can go ahead and integrate with your pipeline. Then you can go ahead and perform a deployment task as well. Once the build is done, you got the artifact from the build, so you are going to deploy into the application. Okay, so let's compare with the current scenario or the existing scenario which we used to do. Okay, what we used to do, we open a Visual Studio, we develop an application, and then we try to build the application. So we are manually used to build the application, and if it's DLL or if it's web application or if it's Windows application, we try to copy those exe DLLs or the files whichever is generated from the build, manual build, which we're doing from the Visual Studio. We try to copy those files into the IIS onto the server. So that's what we are trying to automate. And we had a problem with those existing pipeline, like it will be of so much of manual activity. So one developer is going to build those application. Once the build is done, you are going to give those DLL to the production support team who is having access of the server, where he was going to copy those files over there. Okay, so there are so many manual activity which you can't repeat in the very short span of time. Let's say I want to deploy 5 times in a day. Okay, that is not possible if you do a manual activity. Okay, same application I need to deploy 5 times in a day. I do a small changes, I want to push those changes to the production, or I want to test those into the testing environment. That is not possible if you follow those older way of deploying. So the pipeline helping us into the continuously build, continuously integrating. So integrating means if you have a different application, like yesterday we have talked about the something called technical depth. So technical depth you can scan using something called Sonar Cube and other tool which you can go ahead and integrate. So that's why we call it as a continuous integration. So you are going to build your pipeline, you are going to build your application, and then you are going to do a continuously integration with the different application, and then you are performing some test. So you can write some test case, and you can ask the pipeline to run those tests. If test is success, then you are going to push those changes to the your testing environment or production environment or any other environment. So people, so this is the process which we are going to automate. And pipeline need to be enhanced on regular basis. It's not like that you are doing 2 days you have developed something, so that need to be enhanced, or that need to be redesigned some way to enhance the performance or reduce the bugs and the time. So this is the basics of, you can say, the pipeline and what pipeline is trying to do. Okay, and here it's saying that are those things which I told you just now. So if you see here, pipeline is used to do a repeatable, reliable, and incremental kind of work. Okay, so this is, you have to remember. So this is the important thing why we have to use a pipeline, because I told you that I want to do a repeatable task. I want to do a deployment in 5 times in a day. I want to do a daily deployment early morning, 6 o'clock. Okay, so those time I want to do a repeatable work, and that should be consistent. It's not like that I'm doing today this task, tomorrow I will do this task. So that has to be consistent and bug free, repeatable, and there is no manual intervention is required. So those things you will be able to achieve using a pipeline. If you have them reducing a manual intervention, you are going to achieve a you can say the highly reliable application or bug free kind of application that you will be able to achieve using the pipeline. Okay, so if we are looking at the Azure pipeline, so what Azure pipeline is, so Azure pipeline also gives you the similar kind of feature where you can go ahead and automatically build, test, and deploy into the system. Okay, and this actually, the pipeline whichever we are doing, you can go ahead and works with the different languages. So you can build your application in the Python, Java, PHP, Ruby, C Sharp, and the different languages which you can go ahead and start building those application, and you can use Azure pipeline to build, test this kind of application into the Azure pipeline. You can deploy different kind of different targets environment. You can go ahead and deploy. You can go and to deploy the web application. You can deploy your virtual machine. You can deploy your application into the virtual machine. You can deploy the application into containers. So everything whatever you think, even other than Microsoft, because as you this Azure DevOps, if you are talking, this is Azure services, but you can go ahead and deploy the application even on the different cloud vendor as well. So you have the offer, you can go ahead and deploy to the Azure cloud or Google cloud or AWS cloud, any of the other cloud you can go ahead and deploy here. Okay, so that you will be able to do. Even you can go ahead and build the application using a Windows operating system, Linux operating system, and Mac OS operating. So you are getting all the OS flavor, you are getting all the language flavor. You are going to deploy any kind of application from the Azure pipeline. Even you can go ahead and integrate using a GitHub. Okay, and it also works with the open source project. Okay, also other than this, you can integrate, like if I don't want to use something which is available into the Azure, I can go ahead and integrate with the external tool which is available in the marketplace, like Jenkins, Terraform, Chef, Puppet. So all those things are available in the marketplace, which you can go ahead and utilize that in order to build, test, and deploy your application into the Azure pipeline. So, so that's what the basic of them. But if you're going to develop a pipeline, there are few terms which you need to remember, or you can say the few components of the pipeline which you need to remember. So first thing is the agent. Okay, agent is, you can say, the machine or server where I'm going to put a agent. An agent is responsible, or agent is helping us to build our application. Okay, so if I'm having a .NET code, I can have a machine with the Visual Studio and the .NET framework installed on that, so that I can give the work to the agent. So agent is going to build my application and giving the artifact out of that. So once I have wrote a code here, okay, so this is my 10 line of code and this is my .NET code. I give this work to the agent. Agent is going to build my code, okay, and once the build is done, I'm getting what? I'm getting an artifact. I'm getting some DLL, some exe out of that. That is called a artifact, okay. So the build output is called a artifact, which I'm going to produce or I'm going to send to the delivery pipeline. Okay, so delivery pipeline, or you can say the release pipeline, we are going to do. So what we are going to do, we are going to build our code. We are going to build our code onto the agent and getting the artifact from that particular agent. Okay, continuous integration means as soon as the code has been checked into the source control. So like yesterday, we have changed the code from the Visual Studio Code, and that code, if you are doing any changes in the code, I want to build that code. Okay. So immediately, as soon as anyone is going to check in or committing the code into the pipeline, into the source control, I need to execute a build. So that is called a continuous integration. Okay, we'll see as a practical, then you it will be more clear for you. And once the build is done, so you have triggered the continuous integration flag, you have enabled the continuous integration flag. As soon as code has been checked, build will start. Okay, and after build, once the build is success, I'm going to send it to the continuous delivery. So this is my means I'm going to deploy the application to the different environment. Okay, either it's testing environment or the development environment, or whatever the machine you have where you want to push the changes. And this is what it is called as a deployment target. For the CD, you have to have a deployment target. Okay, so where you want to deploy the code. Okay, so what are the target environment which you have. Okay, and if you are going to talk about the pipeline, so pipeline will have jobs. Okay, so there are a set of tasks which will be created. So job is a set of tasks. Okay, so it will be having a task. Okay, and the pipeline is a step by step process which is going to execute your jobs inside that. So pipeline will have a jobs, okay, inside that, which executing the your task. Okay, release is a process when you are going to deploy those changes to the some of the environment, you can say. So that time I say I'm going to release my code to the environments. So that is called a release. Okay, a stage means a step by step process. Okay, so after this, what stage you want to do? Do you want to dev, after that staging, after that production? So that is stages. Okay, and then you have a trigger. We have a three type of trigger. One is a time based trigger. Okay, so you can schedule on the time that I want to run this at 6 o'clock. Another, you have a continuous integration trigger, means as soon as the code has been checked, I want to execute. Another, you have a manual trigger, which you can go ahead and manually execute your pipeline. So these are the things which you have to consider during the your development of the pipeline. Okay, so these are just a few terms you have to understand. Okay, so any doubt here? We'll do the practical, then I'll talk about these terms. So just to remember these terms, where to fit in, I'll talk about these terms while doing the labs. Okay. So next, if you're talking about evaluation of your something called pipeline, okay, or you can say the, no, evaluation of your agent. Okay, so Microsoft hosted versus self-hosted. So we have two type of agent. So agent, now you are coming. So first terms which we talk about the agent. Okay, so agent, we have two types of agent which is available into the Azure DevOps. One is a Microsoft hosted agent, another is a self-hosted agent. If you're talking about the Microsoft hosted agent, means you don't have a physical or you can say the remote access of those server. There are some random server which will be allocated by the Microsoft. You are not going to maintain or you are not going to log into those server. Just you are selecting that Microsoft hosted. I want to build my code with the Microsoft hosted agent, then Microsoft is taking responsibility and giving running those code into their own servers. Okay, so that's what it is mentioned here. So Microsoft hosted agent maintained and upgraded automatically. It will be maintained by Microsoft. You are not going to access or those things you will not be able to do. So it's behind the scene, Microsoft allocating your instance, or you can say the virtual machine resource, and you are running the agent, and that's it for you. Okay, but there is some limitation with Microsoft hosted agent. Okay, so that's why we are going to move to the self-hosted agent. What do you mean by self-hosted agent? Means you can have your server by your own. Either you can have the server into your own data center, into your on premises, or you can have you can create a virtual machine in the cloud. Okay, and then you are going to install a agent. Okay, so you are going to install a agent, and that server works as a you can say the self-hosted agent. Okay, so that will become a self-hosted agent. Now you are going to maintain, you are going to upgrade. So if any requirement is there to update agent, if there is a requirement to update a server, the patching of the server, the all the controls on the server, security of the server, so everything you have to take care by your own. But the benefit here you are getting, you can go ahead and run any number of time. You don't have any limitation. It's your own server. You don't have a time constraint. If you are going for Microsoft hosted agent, there is a 1800 minute per month. That's what they are allocating you. The Microsoft is going to allocate you. Okay, otherwise if you have you're working with a big organization, and all the process are running with the something called build and release using Azure DevOps, so you will be finishing those 18 hours very quickly. Then you have to buy agents from the Microsoft, or you need to increase the capacity of Microsoft hosted in by paying some money to the Microsoft. Or if you have your own server, own virtual machine, you can install your own self-hosted agent and you can run freely. There is no limit of the jobs, and that is not there with the Microsoft hosted self-hosted agents. So there is no limitation. You can go ahead and trigger as much as possible, and you can occupy those agents by your own. So that's the difference we are getting it here. Now, if you're going to talk about something called a job type, what are the kind of job type we have? So agent does a different kind of job type. So agent pool job we have a container job, we have a deployment group job, and agent list job. So when you're going to develop the agent, okay, there is a type of agent which you have to choose. Okay, so agent pool job, so there is an agent which is going to execute your day-to-day activity, or build agent you can say. Then you have a container agent which is going in container job, which is going to build your container. Okay, then you have a deployment job which is responsible for deploying the code. An agentless job, so it's like where you don't need agent. Okay, so some of the activity doesn't require agent, like waiting time, or some copying the file from one location to another location. So those kind of few of the activity which doesn't require a server to be available directly, you can on the fly you can do those activity. Okay, so that is a something called agentless job. Now, if you're going to talk about the agent pool, okay, so now we have learned about the agents. Okay, now we have agents. So agents are here. So we just now talk about the agents. Okay, so you have a machine. You can install the agents onto the machine. Okay, so we can go ahead and install the machine. This is the one machine which is having a two agent. This is a one machine which is having three agent. So you can organize your agents. Okay, so you can put your agents. So let's suppose that this is my Windows, all Windows Server agent. Okay, so this is my Windows Server agent. So all the server belongs to Windows. This is a Linux server. Okay, so this is a Linux server where I have installed a agent. Okay, so this agent I will club together as an agent pool. Okay, so one agent pool can have all the Windows agents. So when I want to run any of the .NET kind of code, I will give the work to this agent pool. If I have some other application, like whichever I need a Linux operating system, I'll give the work to this agent pool. An agent pool is going to take a responsibility as a load balancer, because what happens internally, they take it as a load balancer. Okay, so it's very much possible that one machine can have a three agent. That's what it's showing here. So one machine is having a three agent. Okay, and when you're giving the work to the agent pool, you are not going to select agent. You are just going to select, I'm giving the work to this pool. Okay, now pool is going to decide which agent is available during that time. Okay, or which agent is performing good. Okay, so my work will be queued to that particular agent, and that particular agent is going to perform the work for me. Okay, so you can organize your agent into your agent pool, or agent pool, you can say it's a boundary for your agent. Okay, or you can say that agent pool will be responsible for distributing the work between the agents. Okay, so that's what you can go ahead and talk about the agents. And Microsoft is going to provide you this kind of agents. Okay, so Microsoft is having a agent pool, so which is Visual Studio 2019, Ubuntu, Ubuntu 16, Mac OS. You have a hosted 2000, Visual Studio 2017. You have Ubuntu 18 as well. You have Mac OS 10.15 also. So these are the agents which is available with the Microsoft. Okay, so Microsoft provide this kind of agent. Just to remember, because this will also come in exam. So what are the flavors of agent pool available into the Azure pipeline, which is a Microsoft provided agent pool? Okay, so this is the you can say the 7 type of agent pool which is available by the Microsoft. Now typically, the if you're talking about the agent pool, when you have installed the agent into your on premises, okay, and you have a machine and you have installed the agent, when you are giving the work to the agent pool, basically you are giving the work to the agent pool, that is getting queued onto the server. Okay, so let's suppose that I have I want to build a project. When I give the work to the agent, what happens that it takes a build definition and it is try to build the application onto the server. It's possible that team project one is trying to build Windows development they are doing, or .NET development they are doing. They can go ahead and build using agent pool one, and at the same project you are using another project, so which is a Java project or some other project, which you can use a machine 2 or agent pool 2 to build your application. So what happens if you are giving a two request to the agent? So if you have the available, if you created a two agents into that and you are giving the two work to this agent pool, one work will go to this agent, another work will go to this agent. This is what it is called as parallel processing. So means the two agents are running parallelly, and that can give a build application and give a response to the particular response. If I let's suppose that this is the two agent I have given. Okay, and I have given a third work also to this agent. Okay, so third build also I have given to the agent pool. Okay, so third application I wanted to build. What happens when this two application is running? The third will be queued into the pool. Okay, so it will be queued into the pool, and pool is waiting. Once any of the agent is free, I'll give this work to that particular agent. Okay, and agent will start executing that work for me. So it will be queued into the agent pool level. Okay, so that's what about. And if you're talking about the security, so you have a different kind of security which is available. Like you can have the reader permission, you can have a service account permission, and the administrative permission on the agent pool level. So agent pool will have, if you're giving a reader permission, the typically the user you are giving the reader permission, he will not be able to modify, he will not be able to do any changes into that pool. He can just go monitor and look into the health of the monitoring kind of stuff he will be able to do. If you are giving service account permission, he will be able to modify, change, and he can schedule those things into the agent pool level. If you are giving administrative permission, he will be overall responsibility he will be having. He can add give the permission to another user. He will be having to modify, delete, all those permission he will be having as part of administrator. Okay, so for the exam perspective, this is also a important slide in terms of what role reader can do, what is the role of a service account and the administrative account in the agent pool. So now, just now I talk about the concurrency. So pipeline and current concurrency. So this is just talking about the parallel processing. When you are giving the work to your agent, what happens? There are few agents which is queued. So you can see this is the third one. Okay, so queued waiting for the pipeline. So this is waiting for the pipeline. Build is running 1 and 4. Build is running, and this is waiting for the pipeline. Another release waiting for the pipeline, and queued build waiting for pipeline, release build waiting for pipeline. So one is a release build, one is a build pipeline, and one is a running pipeline. This is executing currently. So what happened parallelly if you want to execute? So once it is running, the other is waiting. So once this pipeline is completed, this will get executed. Once this is getting executed, another is this is waiting for the approval for the some people. So here it will not go, it will come to the third pipeline, execute the fourth pipeline, and then once approval we got it, we will go to the fifth pipeline. So this is kind of a sequential way if you have the one agent running. But if you have the multiple agents running, what happens? You can go ahead and do a parallel activity. If you want to do a deployment or build activity, those things you will be able to do. Okay, but here it is talking about after one, another will start. So currently you can see this number one build is running, then this release will run. Once release is done, you're waiting for the approval, some approval, then only you want to deploy to the another environment. Okay, so let's suppose that if I'll write here, okay, if I write here, this is my building application. So I build application. Once I build application, I want to deploy to the something called dev environment. Okay, so dev environment I have deployed. After dev environment, I'm looking for the approval from manager. And once the approval is done, I'm going to deploy to the something called testing environment or prod environment. Okay, so that's what I am waiting for the approval here. Now this is some other process which need to be executed, like you want to build some other feature. So this is the feature 1.102 and this is the feature 1021. Okay, so this need to be built and need to be deployed. Okay, so that's what you can do. So after this build, this will be get executed and this will get stuck because approval is required. Immediately you have queued another build which will get executed, and then deployment will happen. And once the approval you have received, you are going to deploy to the another environment. This is talking about the process of the how your pipeline can execute one after the another. This is example of your Microsoft hosted agent. So that's what it is talking here. And if you see here, this is example, that's what I told you. So this is, you can see here Microsoft hosted agent, this is self-hosted agent. Microsoft hosted agent is having a one parallel job. So Microsoft giving you can execute only one job at a time. If you want to do run a more parallel job, what you have to do? You have to buy that. Okay, and Microsoft says that maximum I can give you the one parallel job, one job you can execute at a time. Okay, that's why you see one after that, one after that. It is waiting for that. You can't execute parallelly that build. Okay, so Microsoft is saying one parallel job and 1800 minutes per month you can utilize my agent. Other than you will not be able to utilize my agent. Microsoft is giving the restriction. If you want to buy, you can go ahead and click on purchase parallel jobs, and then you will be able to execute more hours or more parallel job you will be able to execute using a Microsoft hosted agent. Now if you are going to talk about the self-hosted agent, okay, self-hosted agents by default it is 2. Even you can go ahead and increase that by adding a more you can say the agents onto the server, that you will be able to do. But by default it is 2 for the self-hosted. One for free parallel job, another if you have a Visual Studio Enterprise subscription, you will be able to execute using one of that. Okay, if we're talking about Azure DevOps with the open source project, so we have a few open source project which can work. So if you have hosted your code into your GitHub or any other source repository, you can go ahead and use those source control in order to run your code. So Azure DevOps can work with your open source code. There is no limitation, and those things you are not there here. So Azure Pipeline also works with the YAML. Okay, so this is kind of a YAML coding level you will be able to do. So how the pipeline looks like. Okay, so if you are going to talk about your something called a older way of designing the pipeline. Okay, so we have a two-way. One is the classic, and another is the YAML way of deployment. If you are using the classic way, you can see here it's highlighted here. Uh, yeah, so this is what classic pipeline. Okay, so we have a classic pipeline. So classic pipeline, what we are going to do, we are going to edit a pipeline, not edit a code. Once you edit a code, you are going to push the code to repository. Yesterday we have done this activity, and once you push the code to the repository, what happens, your continuous integration means if you have enabled a continuous integration flag into your build pipeline, build task will start executing. Once the build task will start executing, you can go ahead and attach your test task also, which will is doing a unit testing for you. So continuous integration means you are going to build and you are going to test your code. Okay, so that is what it is called, a continuous integration, and this is what it's your build pipeline does. Okay, once the build pipeline executes, build pipeline generates some artifact. Okay, build pipeline generates some DLL, the output of that application. So those things will be generated, that is called artifact, and those artifact will be consumed by your release pipeline. Okay, and release pipeline is going to help you in terms of a deployment into the different environment. Okay, so different environment you will be able to deploy using this artifact into the release pipeline, and that you can deploy into the different environment. This is how your and the classic pipeline looks like a visual designer. So you will be able to see all the tool tasks, and you can just drag, drop, and you can write your customized task and all those things you'll be able to do. So it's kind of visual interface you'll be seeing for the from the classic pipeline. Now there is something called YAML. So this is something called code oriented approach which we are going to use. So this is a code oriented YAML pipeline where you are going to develop a code. Okay, then once you're done with the code, you can go ahead and edit your YAML file. Okay, so this is the YAML file which is having a definition that what needs to be done. Okay, you can go ahead and push that YAML file and the code to the repository. So basically the build definition file and the code will exist in the code repository, and your Azure pipeline executing. So Azure pipeline here, if you see, it does two things. It builds the code and it releasing the code. So two activity, and both the activity need to be written in the YAML file, and then the code will be get deployed. Now you can see here the benefit of the YAML file. You are going to reduce the multiple steps here. Okay, so if you see, only one step, that is called Azure pipeline, does both the work for me. Okay, and here in the earlier step you have another thing, continuous integration. You generate artifact and then finally you deploy into using a release pipeline. So you are doing the build activity and release activity two times using the classic pipeline, but that you are going to reduce using a YAML file, and YAML file is having a one file which is having a both the activity written into that, and that execute once, and which does a build and deployment into the servers. Okay, so you can edit your YAML pipeline. This is the Azure pipeline.yaml file, and that is going to help you, and that pipeline need to be present into your repository, and that is going to help you in build, test, and deployment. So that's the benefit of using the YAML file. You will be getting it here. Okay, so we have a lab here. We are going to just see how we can develop a classic pipeline, how we can develop a YAML pipeline, and then we are going to also look at how we can go ahead and create our a self-hosted agent, and how to use a Microsoft hosted agent here.